All right, another case we might have that's very similar to the last one we just did is in calculating exit dose. So let's just say again we've got our patient here, and we are have a point here at 10 centimeters, and that this let's draw this here. This patient is 20 centimeters thick, and so I'm just going to set it up pretty much like our last problem. We've got a beam coming in from the top. It's a I'll just do a partial percent depth dose table here. So just we've got a percent depth dose at 10 centimeters is 67%, 20 centimeters is 42%. That's what we had from the last problem. Again, we got 180 centigrade at that point at 10 centimeters. And I should mention this is 100 SSD, so it's a percent depth dose problem. And in this problem, we're asked what is the exit dose. So what's the dose down here where the beam is leaving? Well, this problem is actually exactly the same as the last one. In other words, the short way to do this would be to again, I went through the math in the last one, but this is going to be that the dose at 20 centimeters is going to be equal to the dose at 10 centimeters times the ratio of those percent depth doses. So in that case, that would be 0.42 divided by 0.67. Depth at 10 is 180. And like I said, I went through the math in the last problem, but we got that was 112.8. So it's just the same as the last problem, where if you had a point somewhere inside the body, the exit dose, if you just take the ratio of the depth at 10, the depth at 20, and you get 112.8. However, the only difference in this problem is that this answer is actually not exactly correct. And I've seen it asked on tests before. They might say, well, this you measure you put a little measurement device here on the exit, and you do not get this answer. You might get something a little less than that. So maybe you got 110 or 109 centigrade. And they ask for the reason for that. The reason that happens, why you would expect to get a little bit less dose there, is that the dose to a point comes from two main sources. Most of the dose to any point in the patient is coming from a direct beam, so just the dose that you get coming straight down to that point. However, there's a small amount that comes from scatter from points around there. So in other words, some photons might come here, and then some of the electrons or photons scatter into that point. And that comes from both from the front, from the side, and from the back. So a point down here at the exit is going to be missing the scatter that would have come from in front of it, because it doesn't really get scattered in the air. So these exit points, so this will actually be a little bit lower. So you might see that on a test. It'll either ask for the reason for that, or would you expect this to be higher or lower. So in the case of exit dose, we can calculate it using this ratio of percent depth doses, but the actual answer will be slightly less than that due to loss of scatter.